Now that we've got a fundamental idea of the organization of an atom and the electron configuration in a variety of atoms, we now have all the tools we need to build and to understand the periodic table. So the periodic table is organized in a way that shows the electron configuration of atoms. Now, the electrons in inner orbitals, the lower orbitals, are important, but really it's the outer orbits, the outermost orbit, that determines the chemical properties of an element. And that's what we see in the periodic table. Now, the rows are in a periodic table are what we call periods. The columns are family groups separated by alkali metals, alkaline earths, halogens, noble gases, and others as well. And then we have A group families and B groups. The A group family being the main group of representative elements, and B groups would be transition elements or metals. All of that you can see more in your textbook. But here's what how the periodic table is organized. Remember that the electron configuration fills up in the order shown in the figure on the right. First, it's the 1s orbital, then the 2s, then the 2p, 3s, 3p, 4s, 3d, 4p, 5s, and so on. Pardon me. So that is the electron configuration that we have seen. So the periodic table is organized in rows and columns. Again, we said the rows are periods. Each period represents the outermost electron shell. So, for example, the first period, you're going to fill up one electron, so this will be in the 1s1, that would be the electron configuration, and helium would be 1s2. But then you finish the first energy level, now we go to the second energy level. So we'll have 2s1, 2s2 for lithium and beryllium. But then the next thing to fill up would be the 2p's. So you'd have 2p1, 2p2, 2p3, and so on until you fill up the 2p orbital. And then you have the 3s's, the 3p's, the 4s's, and then the next thing to be filled after the 4s's are the 3d's. And then the 4p, 5s, 4d, 5p, and so on. The next row actually is important because then we would have the 6s being the next one that's filled. And then after we find the 6s, the next one to be filled would be 4f. One slight change is you're going to have, you're going to have one electron go in the 5d orbital first, and then, see this gap? This gap would be the first row that's down here. This would be your 4f orbital. And then you finish the 5d, and then the 6p, and the seventh row is similar, it would be 7s, 6d1, 5f, 6d, 7p, and so on. And that is how the periodic table is organized. And so we can actually tell the electron configuration of an element merely by looking at the periodic table. For example, remember we did tin in the previous video. Let's do tin again, looking at just the periodic table. Now, tin is element number 50, element Sn. So here is tin right there. You can see that period 1 is completely full, so that's 1s2. Period 2 is completely full, so you have 2s2, 2p6. Period 3 is completely full, 3s2, 3p6. Period 4 is completely full, that would be 4s2, 3d10, and 4p6. And it's level 5 where tin is. So we have here 5s, it's completely full. Then we have 4d, that's completely full. And then of the 5p's, you only have 2 electrons. So that would be your electron configuration: 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, 4d10, and 5p2. There's your electron configuration for tin. Now we need to go through and look at it, do one more for uranium. So uranium is element number 92, element U. That would be down here in this very bottom row. So this is period 7. So we're in this row. That means all of these are filled. That means you've got 1s all the way through 6s2, 4f14, 5d10, 6p6. All of that is filled. Now we just need to add the 7th row. Here's your 7s2. And then you have a that would be a 6d. You have 1 electron in the 6d orbital. And then here we get down to the 5f orbital. So this would be 5f, 1, 2, 3. So if we were to write out the entire configuration, oh, that's a lot of work, but hey, let's do it anyway. So you have 1s2, 2s2, 2p6. That finishes the first 2 rows. Third row would be 3s2, 3p6. That's the third row. Fourth row would be 4s2, 3d10, 4p6. That's the fourth period. Fifth period is 5s2, 4d10, 5p6. And then the sixth period would be 6s2, 4f14, 5d10, 6p6. That's the sixth period. Now the seventh period, we finish with what we just wrote, 7s2, 6d1, 5f3. And there's your electron configuration for uranium. Now, the periodic table tells us more than just electronic configuration. Because remember, the behavior of elements depends a lot on what's on the outer shell of the outer electron orbital of the atom. If you look at the first row, this would be an S1, so that means that there is 1 electron in the outermost orbital. One electron. So the second row, there would be 2 electrons. And then if you jump over to boron, carbon, nitrogen, oxygen, fluorine, and helium, all these each different row, you're going to have 1, 2, 3, 4, left-handmost 1, next 2, 3, 4, 5, 6, 7, up to 8 electrons in the outermost shell. That's the most you're going to have at any time. Now, if you have just 1, 2, or maybe 3 electrons in the outermost shell, you're going to tend to lose those electrons sooner than gain the rest to fill your 8. So it's easier, for instance, for lithium to lose 1 electron than to gain 7 to finish filling. So that's going to leave these as positively charged if these electrons were to leave, creating what we call positive ions. These tend to be metals. Now, if you go on the other side, if you have, drew a little too much there. If you have 5, 6, or 7, then it's more likely to gain electrons to fill the 8 for the outer shell. And since you have more electrons, that's going to be more likely negatively charged or negative ions. These tend to be your nonmetals. This eighth column, these are called noble gases because they are extremely stable. They already have 8 electrons in the outer shell. They don't tend to gain or lose any more electrons. But this region in the middle here, it's kind of all of this. It's kind of fuzzy. This is the borderline between metals and nonmetals. These are what we call semiconductors. But the atomic property of those metals, it's not very clearly defined. Like stone, it's not very clearly first, second, and third columns are metals, fifth, sixth, and seventh are nonmetals. It varies a little bit. And so we have, if we look at the periodic table, it turns out that all of these on the left are metals, and on the right are nonmetals, and then this region here of orange squares, those are the semiconductors that separate the metals from the nonmetals. And that is the periodic table.